Hi, my name is Catherine Linehan, and thank you for coming to this talk today. I'm going to be talking about mining Federal Reporter using machine learning, selected case studies on the popularity of theme-related topics. This is work with my colleagues Eric O, Joel Thurston, Stephanie Shipp, and Sally Keller. We are from the University of Virginia Biocomplexity Institute, Social and Decision Analytics Division. This is also joint work with the National Center for Science and Engineering Statistics, where we work with John Jankowski and Audrey Kinland. We've been working on this project a couple years, and we started with this overall research question of, can we use administrative data to characterize federal research and development, or R&D grants? And this would be to supplement or enhance current survey data collection. This led us to another question of how can we identify R&D topics and their trends in this administrative data? We explored some machine learning and topic modeling methods. Then an even more specific question, which is what I'm going to talk about today, is what can we learn from federal R&D grants administrative data about specific themes such as artificial intelligence or AI or pandemics? And can we identify trends in research topics in those themes? So this is going to involve some information retrieval and text mining. For our data source, we used Federal Reporter, which is a federal grant database with over 1 million grants. We accessed grants from 2008 to 2019, and Federal Reporter, the data for that is actually submitted by the individual agencies themselves. So for example, HHS and NSF. The data include grant abstracts and metadata, such as project start date and funding agency. In order to prepare our data for analysis, we had to fill in missing start dates, deduplicate records, and we used standard natural language processing techniques on the grant abstracts to clean them in preparation for topic modeling. After preparation, we had a data set of almost 700,000 abstracts. And if we look at the breakdown of these abstracts by funding agency, we see that HHS, which contains NIH, makes up about 75% of our data set. NSF funds about 20% of the projects in our data set. If we look at the abstract count by project start year, we notice there is an increase from 2009 to 2011, which can likely be attributed to the American Recovery and Reinvestment Act of 2009, or ARRA. So now that we have this prepared data set, we return again to our research question of what can we learn from this data set about a specific theme such as artificial intelligence or pandemics? And can we look at trends in topics in those themes? So to solve this problem, we broke this down into two parts. The first being information retrieval and the second being topic modeling. In the information retrieval step, we were filtering the corpus of project abstracts to identify those projects related to a theme. And we did this through the use of term matching and latent semantic indexing, or LSI, on those abstracts. Just as an example, for our artificial intelligence themed corpus, we term matched on that particular phrase, artificial intelligence. So if an abstract includes that phrase, we return it as AI related. For abstracts that are related to AI, but don't include the phrase artificial intelligence, we use that method of latent semantic indexing to return those. So once we've done these two filtering methods, we have a themed corpus around, in this case, artificial intelligence. Step 2 involves taking that themed corpus and running a topic model on it. We used non-negative matrix factorization, or NMF, as our topic model. And after the topic model was complete, we did a topic trend analysis, where we basically captured the trend of topic prevalence over time. So what I'm going to focus on for the rest of the talk are the results of two case studies. One was around the theme of artificial intelligence, and one was around the theme of pandemics. And for future work, we would like to create a general process that can be adapted for any theme. So in our results, we're going to talk about two different measures of topic prevalence. The first being mean topic weight. So when we run a topic model, part of the results that come back are a weight per topic for each document. A higher topic weight signifies a higher topic prevalence in the document. When we run a topic model, a document can be made up of multiple topics. So the topic weight tells us which topics appear in higher prevalence in the document. We average the topic weight over all abstracts in the themed corpus. And this mean topic weight provides a measure of how much each abstract is about a given topic. So this gives us a measure of the topic trend over time. The second measure of topic prevalence is the number of abstracts that actually contain the topic itself. So after running our information retrieval filtering process, we came up with an AI themed corpus. And here we have the breakdown of that corpus by project start year and by funding agency. So there was about 1,300 projects between the years of 2010 and 2018 that we used for this corpus. We can see that the frequency by year is increasing as we get closer to 2018, which makes sense as AI has been gaining in popularity. For funding agency, NSF really dominates this corpus, which makes sense as they do house a computer science division. So with that themed corpus, now we run a 30-topic NMF model on it. Topic models can give different results on each run. They are stochastic in nature. So in order to account for that, we wanted to measure the stability of our model. We used these 3 different measures, which I won't go into because of time constraints. But what we did find from these measures was that our model is stable. And here is the results of the topic trends for artificial intelligence. So what we're looking at here is a figure that has mean topic weight on the y-axis for each of these plots and project start year on the x-axis. Each of these 30 plots represents one of the 30 topics from the model that we produced. The plot titles are the top 5 words for that particular topic. So those top 5 words will tell us what the topic is about. We have 2 measures of prevalence represented on here. And the first is that mean topic weight over time trend. And for the trend lines, those with positive slopes are orange, those with negative slopes are blue. And the other piece of information we have on here is the n equals in the upper right-hand corner of each plot. And that's the number of abstracts that include that particular topic. Okay? And all of the plots on here are on the same scale so we can compare across topics. We do want to note that a topic with a decreasing trend could be more prevalent than a topic with an increasing trend. So take, for example, here topic 25, which looks to be about REUs. While the mean topic weight does have a decreasing trend, it is higher than the mean topic weight of topic 7, which is about video and image summarization. Also, we note that n equals 672 for topic 25, which is more than the value of n for topic 7. So even though topic 25 has a decreasing trend, its mean topic weight is higher and its n value is higher than topic 7, which had an increasing trend. So in this case, we would say that topic 25 is more prevalent than topic 7. I want to mention a few notable takeaways from these results. The first being that hardware in topic 1 and deep learning in topic 2 have the largest mean topic weight trend increases over time. That's in contrast to these 4 topics that are highlighted that have fairly steady mean topic weight trends. These 4 topics include machine learning in topic 13, natural language processing in topic 9, and reinforcement learning, which is represented in both topics 17 and 19. We can also see topic 6 is about robotics, and this has a high mean topic weight and a fairly high value for n compared to the other topics. signaling that robotics is a very prevalent topic in our AI-themed corpus. I'm going to come back to this machine learning topic, number 13, and just say a bit more about this one. So we can see that it has a very low mean topic weight, but its N value is very high. And in fact, it's the third highest value for all of the topics. So this suggests that a number of abstracts at least mention machine learning. And what could be happening is they could be about applications of machine learning. For example, topic 15 here, which is a breast cancer topic, where machine learning can be used to classify tumors. So if a document, barely contains machine learning, and the majority of it is about the application area, that would be sort of one reason why we might see these results here for the machine learning topic and the machine learning applications topic. So moving on to the second case study about pandemics, we have here the breakdown of our pandemics themed corpus, where we can see by project start year, we don't have 2020 data. So I want to make a note that these projects are between 2010 and 2019. So this is all pre-COVID data. There's about 2,000 projects in the pandemics themed corpus. And the dominant funding agency for this corpus is HHS, the Department of Health and Human Services. Again, we run a 30-topic NMF model on this corpus, and we calculated the 3 stability measures. And again, we found that our model is in fact stable. So here are the results, and the figure is set up exactly the same as was for the AI case study. And again, we make a note that topic 30, which is one with a decreasing mean topic weight trend, is more prevalent than topic 2, which has an increasing mean topic weight trend. So topic 30, its actual mean topic weight is higher than that of topic 2, and so is its N value. And topic 30 happens to be about HIV and AIDS, so we would say this is a more prevalent topic than topic 2, which is about the influenza A virus. A few notable takeaways from this case study. We'll start here with topic 8, which is about influenza vaccination. This has the largest value of N for all of the topics in the corpus, and it's actually the largest amount by far. So this topic comes up in more than half of the documents in the pandemics corpus. And it has a steady and high mean topic weight. So this would lead us to conclude that this is a really important topic in the area of pandemics that shows up in our data. Other notable takeaways here, coming back to both influenza and vaccination. We see vaccines here, and I've highlighted 4 topics about vaccines, are also really prevalent themes in the corpus. Each of these highlighted topics have a high mean topic weight and high values of N. We also see that influenza is a very prevalent theme. So I've drawn boxes around 9 different topics that are about influenza. And how we measured that is that influenza, or a word that signals influenza, was in the top 20 words for each of these topics. So influenza is very prevalent in the corpus. It makes up about 1/3 of the topics. And we can see there are some other health issues that come up, such as obesity in topic 3, tuberculosis in topic 7, but influenza is incredibly prevalent. It makes up 1/3 of the topics. So for present and future work, we plan to improve our information retrieval. We have an ongoing literature search to see how others are solving this problem. We'd also like to create a keyword list for our term matching. That would include synonyms of the theme as well. And we'd like to use themed wiki pages. So in other words, the AI wiki page as our ground truth, and then score that similarity with each grant abstract. So we can do this and add synonyms to the keyword list by using word embeddings. We'd also like to test the performance of the retrieval using precision and recall, and compare automatic and semi-automatic methods. Lastly, we want to investigate other themes such as bioeconomy. Thank you for listening to this talk. I hope you enjoyed it.